Welcome back. So, in our previous video, we examined the concept of outer joins. In this video, we're going to run a couple of example queries to see cases where outer joins can be helpful. To restate what we discussed before, the key use of outer joins is to execute joins where we need all the entries from one table, no matter if they have matching entries in the other joint table. Let's see one example. We want to identify movies in our database that do not have any actors associated with them. How can we find such a movie? We'll start with the basics and take a look at the tables that we have. So we go in the movies table, we type select star from movies, order by ID, and we see that we have movie 0, number 28, released in 2002, movie 1, number 7, Train, movie 2, movie 3, and so on. As you can see, we have the movie IDs 0, 1, 2, 3, and so on. Let's go and take a look at the roles table. Similarly, select star from roles, and I'm going to order by movie ID. Let's take a look now. You see that we have two role entries for movie 0, number 1 man and number 1 woman. Notice now we have no entry for movie 1. We go directly to movie 2. We have entries for movie 3, 4, 5, 6, and 7, but we don't have anything for movie 8. We don't have anything for movie 10, and so on. So notice that I have the order by movie ID, so there is no way that these movie IDs appear somewhere else in the roles table. How can we find such movies that are missing from the roles table? Let's start and do the inner join query that we have tried before. So we go and write select star from movies M, inner join roles R on MID is equal to R.movieID, order by M.ID. Here's what we have. We have movie 0, number 28, released in 2002, and we see that we have the two entries for number 1 man and number 1 woman. We also have the entries for the actors of movie 2, the actor entries for movie 3, but if you notice, we don't have anything for movie 1. Movie 1 has just disappeared. It doesn't have any matching entry in the roles table, so it doesn't show up in the results of the inner join. Similarly for movies 8 and 10. If we query just the movies table, we see them, but if we do the join, they don't show up in the results of the join. So why is that? Because we have an inner join. An inner join returns back only the matching roles. So now let's see how we can use the outer join to get back the missing movie entries. What we are asking now is the following. We want to do the join, but we want to get back all the entries from the movies table, no matter if they match any entry in the roles table or not. So we are going to change now the inner join to a left outer join, with movies being the left table. So we type select star from movies M, left outer join roles R on M.ID is equal to R.movieID. And we're going to order by M.ID. Notice the meaning of left. The movie table appears to the left of the outer join. In other words, appears before the outer join. By changing from an inner join to an outer join, we are asking to get back all the entries from the left table. The movies table is the left table in this expression, so we'll get back all the entries from the movies table, no matter if the movie entry matches with one or more rows from the roles table. Let's take a look at the results. We are going to compare now the results of the inner and the outer join. Take a look at the results of the inner join. Notice it doesn't contain an entry between movie 0 and movie 2. Now let's switch and see the results of the outer join. You see that we get back the entry for movie 1. Notice that the columns that come from the roles table are now all filled with null values. Pay particular attention to the attributes in the join condition. The ID from the movies table and the movie ID from the roles table. These are the attributes that we use in the join condition. In the, let's say, regular results, that also appear in the inner join, these two columns have matching values, because this is what the join specifies. However, whenever we have non-matching entries in the outer join, the movie ID from the roles table is null. This is a signal that this row contains a non-matching entry. You'll see these null values also for movie 8 and movie 10. The movie ID is null, and also the role and the other attributes from the roles table are null. So these are effectively the movies that don't have a match in the roles table. At this point, how can we say, give me now back only the movies that don't have any matching actors? What are these movies? These are the movies where the attribute in the join condition will be null. So we write where R movie ID is null. Notice that I specify that the movie ID from the roles table needs to be null. This is the matching attribute from the right table, and if this attribute is null, we know that we have a row from the left table that didn't match with anything on the right table. Notice that I don't use the role or the actor ID attributes, even though these are also null in the results. The reason that I don't do that is because these attributes may be null in the roles table, so we can have an actual match that may still have null values in these attributes. However, we cannot have a null value in the matching attribute of the right table if the rows do have a match. Now, let's execute the query. We get the number 7 train movie, no actor ID, no movie ID, no role, and so on. And the remaining movies that you see in the results are all movies without actors. Now let's do another example. Let's try to find all the movies that don't have an associated genre in the movie genres table. How can we do that? Let's take a look at the movie genres table. So select star from movie genres, order by movie ID. Notice that we don't have an entry for movie 0. We have genres for movie 1, short and documentary. Movie 2 is crime and comedy. We don't have any entries for movies 3, 4, and so on. We have for 5 and 6. We don't have anything for 7, and so on. We want to find the movies where we don't have a genre. This is another example where an outer join can be helpful. We'll join the movies table as the left table, and we'll see which movies from the movies table do not match with an entry from the movie genres table. Let's start with an inner join to make the comparison easier. Right? So we type select star from movies M, inner join movie genres G on m.id is equal to g.movieid, order by m.id. You'll see again that we get back only the movies for which there is a genre associated with them. Nothing for movie 0. We have movie 1, movie 2. Nothing for movie 3 and 4, and so on. Now, we are going to change this query into an outer join. We want all the movie entries from the movies table, even if they don't match anything in the movie genres table. Since movies is on the left, we change the inner join to a left outer join. So select star from movies M, left outer join, movie genres G on MID is equal to G movie ID, order by m.id. So everything is the same, we just change the inner to left outer. Now, let's compare the outcomes of inner and outer join. For the inner join, we have the movies 1, 2, 5, 6, and their associated genres. Here is the corresponding result for the outer join. Notice that we get null values in the movie ID column for the movies that do not have a corresponding genre in the movie genres table. So again, now we are going to limit only to movies without an associated genre, and we specify where g.movieid is null. Again, remember we need to make the condition is null on the matching attribute that we use in the join condition from the right table. In other words, for us now it is the movie tables G and the movie ID attribute. Again, this is the one attribute which is going to be null whenever we have non-matching rows. And with this example, we conclude our discussion of outer joins. You can practice more on your own by trying to find, for example, people in the Facebook database that don't list their majors, people that don't like any book, people that don't like any music, and so on. So these are all examples that you can try yourself in the Facebook database. This video completes our discussion for joins. Joins let us combine information from multiple tables in a database and create views of the data based on combinations of the data stored in different tables. We spent most of our time focusing on inner joins, as this is by far the most commonly used operation, and in the last couple of videos we also examined the concept of self-joins and outer joins, which are a little bit more advanced but still very useful when you need them. At this point you should feel pretty comfortable reading an SQL query that contains a join, and you should be able to understand what the query is doing. As you will practice, you will find yourself more comfortable creating queries with joins, and you will see that very quickly it will become a natural act. If self-joins and outer joins still seem hard, do not worry, it's absolutely normal. We'll encounter them again in the future. We are going to practice a little bit more, but remember, these are a little bit more advanced concepts. In our next set of videos, we are going to study aggregation queries, one of the most useful and widely used parts of SQL. Until next time, play around and practice. See you next time.